Hello, this is Group 4's video submission for 3C8 Project 2. We were tasked with the rugby radio signal project. Due to the fact that our circuit has 4 main blocks, we have decided to split this presentation into 4 parts with one person delivering each part. Let's begin.
So this is part A. It is the preamble detector. We use 2 monostable multivibrators. One detects falling edge and it is non-retrievable for 400 milliseconds. One detects rising edge and it has a RC value of 40 milliseconds. And the outputs are ANDed with a logic high and a logic low from falling edge. And this would give a 1 when it detects a minute marker. The logic behind the design is described in this diagram. So QB falling edge would give a high for 400 milliseconds at the initial falling edges. And QA, in the case of second signals, it will give a higher here, and so the output logic and it would be 1 and 1. And in the case of minute marker, it would go high at the end of the 500 milliseconds, and it will give a logic of 0 and 1. And that is the logic behind a preamble detector.
Once we have the minute marker, the next obvious thing to do is to count the number of seconds. This is done by synchronizing the signal received with the counters. We know that every second is denoted by a falling edge. Using that, we are able to generate this clock signal in part A, which keeps track of the seconds. For every rising clock, we increment this ones counter, and when the counter gets to 10, we reset the ones counter and increment the tens counter by 1. This is done using the preset enable 1 signal. As you can see, this has been fed into both ones counter and the tens counter. The tens counter is reset when it gets to 6 using this logic. This way the seconds will go from 0 to 59 seconds. The output of the counters are fed to this BCD to 7 segment decoder, which is then displayed using these 2 7 segment display units. One more thing to point out here is the use of SR flip-flop. We have used this to ensure that this circuit is only activated once we detect a minute marker. When the start of the minute is detected in part A, master reset gets logic 1. Only at that point the output of the flip-flop will be high and remain that way throughout. This, ANDed with this clock signal, ensures that the counter and ultimately the entire circuit is only activated after detecting minute marker.
The 8-bit detector circuit is very similar to the minute marker detector circuit. The differences are that it is reset and run every second. It also has a smaller RC value to detect the part of the signal that actually contains the 8-bit.
The 8-bit detector is exactly the same. It is described in this diagram, and you can see the comparison. That the 8-bit detector, the only difference is that it is a shorter RC time constant value.
This high is then outputted to the hour and minute display for that second of the clock.
The hour and minute information is received between the 39th and the 52nd second of every minute. Due to this, we created a logic that would stay high just for this time period. Using this, combined with our second clock, we shift the A bits into 2 serial to parallel registers that are then output into 4 counters that are set up the same way as the second counters. There is then 4 BCD to 7 segment decoders and 4 7 segment displays that show us the hour and minute information for the signal. To end this presentation, we will show you a full demonstration of the circuit working with the signal that was provided to us. This will be a time lapse as the actual time taken with the software is 4 minutes.